And the one that I take has 50 billion, I don't know what, bacterias in it. And then there's some that have like 100 billion bacterias. So I always take the one that has the most billion bacterias. I don't know what those billion bacterias are, but I figure the more billion bacterias I have, the better. I know bacteria is good and yogurt and those kind of things, so I try and do that. But I think this episode's going to be really good because I don't really know what bacteria is supposed to do. But I know it's good. I know it's good, and I know we should do it. And let's get to it.
This is Fat Science, a podcast dedicated to the science of why we get fat. No diets, no agendas, just science that makes you feel better. This podcast is for informational purposes only and is not intended to replace professional medical advice.
I'm Dr. Emily Cooper. I've been treating patients with metabolic issues for over 25 years. I'm on a mission to raise awareness about metabolic dysfunction and why diets don't work.
Hi, I'm Andrea Taylor. I've been fat, very fat, chubby, morbidly obese, and done almost every diet ever invented. They all worked until they didn't. I've known Dr. Cooper forever, but when I became her patient and we learned metabolism was the real problem, wow, everything changed, and I've never been healthier.
And I'm Mark Wright. It's time for Fat Science.
Wait, does this podcast make me look fat?
Welcome to Fat Science. I'm Mark Wright, along with Andrea Taylor, who's cracking herself up, and Dr. Emily Cooper. We were just talking before we started recording about bacteria, and I'm sorry that I asked Andrea about it.
I know.
She started talking about all kinds of crazy
Bacteria.
stuff. Well, this episode is going to be really cool. Who is in charge of our fat, our brain, or our bacteria? So I did a little homework last night, you two, and I found out that we have a freakish number of bacteria and microorganisms in our bodies. We have something like 30 trillion cells in our bodies of our own cells. But Dr. Cooper, how many other critters are in our bodies?
Well, that's like the really fascinating thing is we're walking around with like 4.5 pounds of microorganisms pretty much.
Oh my God.
And we actually have
But we want them. We want them.
We actually have a lot more of the microorganisms than our cells. So it's actually 100 trillion. So it is quite a lot more. And also what's interesting is the genetic material is a lot more as well. So our genes, our actual genes make up the human genes, make up 23,000 genes. And the microbial contribution is an additional 600,000 genes. So actually our genes only make up like 4% of the entire microbiome in our body. And the rest is all of these microorganisms.
Wow. Mm-hmm. I've heard, Dr. Cooper, that scientists say there are many undiscovered critters. Have they identified all the different types of bacteria that are inside of us?
No, they haven't. And, each type has different substrains, and it's really a kind of a mystery. When you start listening to the experts in the field, there's some things that are kind of established and known, but all the scientists say that it's really largely unknown what is going on, like what's healthy, what's not healthy. And we have a general idea, so that's good. But there's so many different strains, and they really don't know, haven't been able to identify all of them.
Wow. And they're all living there in our guts?
Well, they live all over our body. So not just in our gut, although the gut is definitely like the largest contributor, but the skin and the urinary tract and our vaginal area and all over our body contains these microorganisms everywhere.
Wow. So what is the purpose, Dr. Cooper? And then we'll get into how these interact with our metabolism. But what's the purpose of all these things living on us?
Well, if it wasn't for these cohabitants, with us, we would not be as healthy. But then again, that's provided that our gut flora and our microbiome in general is healthy. And so that's why it's really important to understand, what it's all about. But it's not just bacteria. That's something to keep in mind, because it's also fungi and also viruses. And it even can contain certain parasites too. So most of it probably is bacterial, but there's other organisms within that. And what it does serves a lot of important functions, really. But one thing to keep in mind is, how do we even develop it? I mean, that's like a question. Well, where did it come from? How did it get within us? And what scientists have found is that most of our microbiome is kind of established by the time we're like 3 years old. So it can change through life. And as we age, there are some things that tend to change, but the foundation of it is established really early on. So at birth, so it depends on, is this a vaginal birth or a C-section? That actually will change our initial microbiome. And then it depends on our early diet, like breastfeeding or formula or different kinds of foods that are introduced at an early age. That can really impact that microbiome. And then also, like, some infants might be exposed to antibiotics and things like that really early, which could affect it. But what they found is people living all over the world have different kinds of organisms and different level of what's called diversity, which means like all the different organisms that are there. And then when people move from one location that their ancestors have grown up in to another, it can actually start changing their microbiome, which colonies are actually populating it. So, but the greater the diversity of it, the more health benefit. And that's what's been shown. And so it's very important to have a diverse level. And that would be because if you don't, it could really allow the growth of some unhealthy microorganisms. So as long as the population of all of these microorganisms is like really varied, then it's not likely that some unhealthy strain is going to just take over and fill some kind of a void. So the diversity is just really important. And without the diversity, it's shown to be associated with certain diseases. And that's what's kind of interesting. That's why it's so important, because diverse, healthy flora is associated with reduced disease risks, including obesity, including diabetes, including inflammatory bowel disease. But an unhealthy, less diverse mixture is also associated with negative effects on our health, like atherosclerosis, diabetes, all of that.
So all these things are like microscopic, I'm guessing, but what role do they play in how you digest foods and how you process foods when you're eating them? Like, what
Yeah,
happens?
well, it does affect our digestion a lot. The gut flora affects our digestion. It also affects our absorption of key nutrients and even the manufacturing of certain vitamins like B12 and K and certain amino acids. So with this gut flora being healthy, we actually can be in a better nutritional state because we can absorb more of the nutrients from our food, and we can actually manufacture some key essential vitamins and amino acids that our body can't produce. And so we're reliant on these organisms to produce these for us or help us to produce them and absorb them. The other thing that the microorganisms do is they produce something called short chain fatty acids. And what those do, there's a number of things, but mainly they create a barrier for our gut so that it's not permeable, because you don't want the contents of what's inside our gut to start oozing out of our gut into our internal organ area, into our body. We want it to stay within the gut so that it can continue processing and then eliminate the waste. And so if not for this flora that we have, the microbiome, we would not have that protection. And then we would have a permeable gut that is releasing toxins into our system. And that's often referred to as leaky gut, but I like the gut permeability phrase better. It seems a little bit more medical. But so the short chain fatty acids are really important for that. And then they also provide fuel for the colon as well, for the colonic tissue. And reduce inflammation, improve our immunity. So all of this is just so important. The other crazy thing is that things like serotonin that we associated with mood, 90% of it is produced in the gut by these bacteria. So people often who have depression and mood disorders take SSRI medications to try to boost the serotonin levels. But you could see how our gut flora could make a difference with our mood.
Do you get or can you boost some of these gut floras with food or with anything like that? Or is it just established and there?
No, well, that's a good point. I mean, it's largely established initially, but you can make a big difference. They've done numerous studies that show that it does matter, how we eat. Food, nutrition is the key way to change it, I think, because really it's what we feed, especially since most of our microbiome is in our gut. What we eat is going to affect the gut microbiome, which is the most prolific in our body. So what they've found is if you eat a diet that is low in certain types of foods, your bacteria doesn't like it. I mean, it wants nourishment, and so what helps it is things that are a little bit harder to digest, actually. It kind of feeds off of that. And so it would be like the fibers that are found in whole grains, beans, legumes, fruits, vegetables. A lot of plant material is very good for the gut and for the gut flora. And it literally feeds off of that. And there are some beneficial effects of even the gut, the microbiome waste products as well. The microbiota, it's called, the organisms, and the microbiome also consists of the waste products of the organisms. But so we actually benefit from all of that potentially. And so as long as the flora is the more favorable, health promoting, that produces those short chain fatty acids and helps us absorb and manufacture nutrients, as long as it's that balance, then it keeps us healthy. And so eating foods like that can be really helpful. Other foods that have been shown to be helpful are things that have high levels of what are called polyphenols, which are colorful foods, colorful fruits and vegetables, coffee, tea, cocoa. They're also found in olive oil and things like that. And so, but diets that are high in meat and animal proteins and animal fat are not as beneficial for our gut flora. And it's not that you should avoid it altogether necessarily, but more and more studies are showing that it causes a shifting in the bacteria, which is referred to as dysbiosis, which is that imbalance where it starts to favor the unhealthy flora with less diversity. If we eat a lot of animal proteins and animal fats, that's not great. And it can produce a byproduct, which is called TMAO, which is associated with increased risk of coronary artery disease even. So we've started in our clinic measuring TMAO levels clinically, in people that seem to have higher cardiovascular risk, just to kind of see if we're getting any clue about their potential makeup of their microbiome and if anything can be done about it.
It sounds so complicated, this symbiosis, this sort of orchestra of organisms in our bodies. But when it comes to metabolism, Dr. Cooper, what role do the gut bacteria play in that loop of metabolism that manages how our energy is used and stored?
Yeah, I think a lot of it comes from, again, that nutrition foundation. Because as we know, to have a healthy metabolism, you have to be nourished. Your body has to at least perceive that you're nourished. And there can be glitches where your brain doesn't really perceive it correctly. But if you're actually not nourished, it's worse. So getting the flora to produce those key vitamins and amino acids that we really need, that's one step of how it can strengthen our metabolism. But the other interesting thing is the gut flora affects the hormones that are transmitting signals from our gut to our brain. So hormones like GLP-1, which is very popular because it's a medication group that's getting a lot of attention. But GLP-1, GIP, PYY, and then in addition to affecting those, it can also affect other things like ghrelin that we've talked about, which is a hunger signal from the stomach, and it can affect leptin, which is a security signal from the body fat. So it can also even affect our cortisol levels. And so it makes this huge difference. It's like a communication adjuvant. It's like an aid to the communication between our gut and our brain. If you have healthy flora, gut flora, it really aids that healthy communication and healthy hormone production.
Okay, here's my question. What's all this about lactobacillus? I just like the fact that I can
That
pronounce
was very
it. It's
good.
amazing.
Very good.
but I hear it on like TV commercials for like those little yogurt shots that you're supposed to drink or whatever. But they never say, they say, oh, it contains lactobacillus. But like, I don't know what the hell that is. It's supposed to be good. So
It is. Well, it is one of the
do we want it?
Yes, we want it. It's one of the microorganisms that's been shown to have health benefits. So lactobacillus and bifidus are probably the most. Bifidus is another one, the most studied for their impact on potential disease prevention and just maintaining the health of the microbiome and preventing the overgrowth of unwanted pathogenic bacteria. So that is usually in most over-the-counter probiotic supplements and things like that. You'll see lactobacillus and bifidus strains in there. And those are thought to be on the kind of healthy list of flora.
And those are defined as probiotics.
Yes,
right?
because probiotics are the actual microorganisms. So if something, and there's a lot of nomenclature that's been put out by the FDA and the World Health Organization, but technically anything that is a living organism, microorganism, is in the probiotic category. And so that would include the probiotic supplements as long as they really are live. You don't know, so you have to do some research to see if they really are. And that's why refrigerated is sometimes a better assurance that it is maintained in a way that it's live, but that doesn't mean that it's not live if it's not refrigerated. So I think you have to look at the product information and try to get to the bottom of how do you know for sure that these are live cultures. Same thing with foods. Certain foods have live cultures like yogurt and kefir. And so those also are probiotic foods.
What is kefir?
Kefir is like a liquid yogurt. And other things that are fermented foods also have little microorganisms in them, like sauerkraut, pickles, miso, tempeh. So there's a lot of different things. Kimchi. There's a lot of things there that have these little microorganisms, and they have probiotic properties, foods as well as these supplements that contain live cultures.
A friend of mine is like a sauerkraut guru. His family is Germanic in heritage. So he went to an antique store and bought me an antique stone 5-gallon sauerkraut crock. And he helped me with the shredded cabbage and salt and everything in the right proportions. I have never had better sauerkraut than the sauerkraut that was produced in my garage. It almost was carbonated in terms of the sparkle. When you put it in your mouth to eat it, it had this freshness and this effervescence that was unlike anything I've ever had before. It just made me think, oh my gosh.
Wow.
Wait, I thought when it sparkles, it's bad. I
Well,
thought when things are sparkly, that's no good.
It can be okay. You have to part of the way of eating to improve your flora involves making sure your gut can handle some of these things and maybe take.
I mean, I love sauerkraut. So
yeah.
And Mark, you have that great Guard organic farm. So hopefully we'll see some sauerkraut this year.
Well, Dr. Cooper, it reminds me, my grandmother, who lived to 97 years old on the farm in Ferndale, she would grate vegetables like carrots and cabbage and celery and whatever, put it in a bowl on the kitchen counter, a stainless steel bowl, put salt on it, toss it, and it would just leave it on the
Wow.
countertop. And then several days later, it would be
Hmm.
fermented because of the natural bacteria that were in there. And then she would eat it. And
Delicious.
she was so healthy, but it just makes me think that that's just a really simple way that we can get more of these good bacteria in our bodies.
Yeah, I
right?
mean, I don't know about
Right.
the food safety and preparation, but I definitely think that fermented foods are great. And if you like, a lot of people really like, you could pickle beets, you could pickle like anything pretty much, and
Yeah.
it does enhance it. The other thing to think about is, the difference between probiotics and prebiotics, and then specific kinds of foods that affect the flora. Like probiotics are, as we said, living organisms. The prebiotics are foods that influence the microorganisms. And so they can, affect the fuel of the microorganism and provide better fueling and better environment. And so typical things like that are things like garlic and onions and leeks. So some people can't eat foods like that, but if you can, those are also really beneficial and they promote the growth of the healthy flora. So do bananas and sunchokes, which are also called
Oh.
Jerusalem artichokes. Those are also known to be good, and apples and beans and legumes, stuff like that. But the other interesting thing is that starches are really beneficial. And there's something called resistant starch, which I'm not sure if people are aware of this, but it's definitely much more beneficial if you can consume starches in a certain state, which is called resistant starch or soluble fiber. So soluble fiber is pretty straightforward. That's like oats and barley, that kind of gooey type of grain. That's very beneficial, but also the resistant starches are great. And all that it takes to kind of make a starch more resistant is to let it cool after you cook it. And so, like potatoes, potatoes, sweet potatoes, all of those starchy vegetables, and also pasta, rice, grains. If you cook that and then you let it cool, and then you can do whatever you want after it cools. You can reheat it or you can eat it cold. It has changed the structure of the starch, just the cooling mechanism. And that makes it a resistant starch that promotes a healthier gut flora and actually has been shown to improve those hormones, that affect our metabolism. So that's something to keep in mind. I mean, when I cook, I do make like big batches of everything just to save time. So it ends up where a lot of it ends up in the freezer and then you reheat it, or the fridge, and you eat it the next day. And so that's actually really beneficial to do that.
Huh. So who's in control here? The brain or the bacteria? What's controlling, it's basically a which came 1st
Mhm.
thing in some
Yeah.
ways. Like, who's making the decisions?
So many things I run into in medicine are that way, where you can't, like, what comes first, and you get caught in a circle there. Really, the more you think about it, it's really hard to say because the brain is the ultimate decider. But if the signals are hampered because our flora is dysfunctional or out of balance, how will the brain have the right information to process? And so having a healthy gut flora seems to me to be instrumental in aiding the brain to see a clear picture of, what's really going on in the body to enable a healthy metabolic response. But so I think ultimately the brain is the decider. It's going to be in charge. Our gut flora doesn't really directly regulate our metabolism, but it does indirectly influence all of those incoming signals to the brain. And so I think it can make a huge difference one way or another. If our gut flora is in that balanced state that promotes that health, or it's in that imbalance where it's really now promoting disease. So it is hard to tease them apart.
Dr. Cooper, we've heard of these fecal bacteria transplants from one person to another. Is that something that has been proven effective in people who maybe don't have the diversity of bacteria in their colon?
It's interesting. It's being done more and more in specific subgroups. And I think there are actually some now better quality studies that are going on in humans. Most of the research has been done in mice. And So that's not that helpful. It's kind of frustrating when you're looking it up and all you see is mice, 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 mice. Because we just don't know how that would really translate into humans. Mice are just so different. But in mice, there were a lot of clues that it can make a big difference with their tendency toward obesity, diabetes, and things like that to do these fecal transplants. But in humans, there's not enough data to see. But one interesting thing that they've shown is after like bariatric surgery, for example, the gut microbiome is very different after than before. And it changes in a very favorable way. So the question is, how is that happening? And in my mind, yes, these gut microorganisms influence those incoming signals to the brain that regulate our metabolism. But in people that have higher body weight, that's known to be a little bit off balance, some of those gut hormones. And so you wonder if just restoring some of the hormonal aspect, the metabolic strength, if that changes the flora. Again, it's one of those which comes first kind of things. Is it that because we see also with GLP-1 medications, you think about that. Well, those slow down the motility of the gut. And so they probably are changing the flora also in the gut to a maybe more favorable type of flora. And so is that part of how they're working is what you wonder, and is it that, so again, what comes first? Is it that these medications and procedures to treat obesity are changing our gut flora and that's helping? Or is it that they're improving our metabolism and then that's changing mechanisms that allow our gut flora to flourish better? So I don't know if I explained that right, but it's like, it's always in science, you're trying to figure out cause and effect, versus just association. And so I think with the fecal transplants, we don't have enough information to really understand that.
But we do know that this entire system is in constant flux because, like, if we go on antibiotics for an infection, doesn't that kill a lot of the good bacteria in our gut?
Yes, that's really antifungals too, because remember, some of the microbiota are fungus as well. And so antifungals, antibiotics, they definitely wipe out a lot of the beneficial bacteria and they make way for unhealthy bacteria to develop. And so that's probably a good time to start really ramping up the probiotic foods and take maybe a probiotic, make sure you have the prebiotics in there to try to restore that.
That's interesting.
Yeah. So I guess what I'm hearing, Dr. Cooper, is that, we're often encouraged to eat living food, like try to avoid highly processed food as much as possible because, when I was a kid growing up on the farm in Ferndale, we would just pull a carrot out of the ground and wipe it on our shirt a little bit and then eat it. And I'm just thinking how good that must be for the microbiome when you're eating good soil.
Yeah. And I was just going to say a little dirt, they used to say a little dirt is good.
It's true. I think that's
true.
One thing to think about. Like, even you want to balance it because you definitely want to protect yourself from, pathogens out there. But are we like showering too often? Are we washing our hands unnecessarily? Like, we want to wash them for good hygiene, but do we really need to wash them every single time we touch something? And then what about our kids playing in the dirt? That has been shown to be beneficial. Having pets in the house, beneficial. So it's one of those things that our society, you start to become too sterile. That could also create some real problems with our microbiome.
That's interesting. It sounds counterintuitive, but yeah, those studies that show that pets in a household, the dog licks all kinds of stuff and then licks the baby's face and all that good bacteria gets in there,
because it's thought that the good bacteria then produces those short chain fatty acids, which really improve our immunity. And so it reduces the risk of allergies and asthma as you get older as well. So I think more and more, starting out where these are associations they're seeing, and now more and more it's seeming to be causative, like it really does impact it. So, and Even with dermatology, there's a big focus now on the flora that's populating our skin and rosacea and acne and all of that. And they're even talking about ways to do transplants, flora transplants, microbiome transplants to the skin. Is there a way to evacuate what's there somehow and then replant it, with more beneficial organisms? And so
Wow.
it's pretty interesting, all the different areas that are being studied.
Well, the biggest thing in skincare, what is like pigeon poo
Uh-oh.
and snail
Oh,
oozy is
yeah.
like they use it in facials all the
Yeah, so
time.
they're trying to get
So
it.
I don't
And
know.
what that's interesting. I think that there's
Oh,
some,
man.
I know
well,
it's
there
gross. I know it's
maybe
gross.
that could work, but I think it's some marketing, because my understanding is that the microorganisms are not on the surface of your skin as much. They're in those hair follicles. And that's where you really would have to get in there and strip out to try to like access that area to really change the environment. But and they do show that improving the gut flora does have some impact body wide on our whole entire microbiome.
Well, as we wrap things up, Andrea, any final thoughts, any takeaways on your part?
I think we got to eat more sauerkraut. I think that we're all coming over for the sauerkraut. I'm a little hesitant about the bubble sauerkraut, but I'm willing to try it because I am a sauerkraut fan. But I think this is like saying that what we've been thinking about and hearing about
Right.
forever, the more roughage, like your mother said, your grandmother said, eat your
Yes.
roughage. It was, but now we know about it from a different reason to eat your roughage, that it's all about these things that we need to have in our system, that it's really good for us and will help our metabolism. So it's a good thing.
Absolutely.
Yeah. I don't know if they still make it, but there was a cereal when I was a kid that really was pretty much like ground
Grape
up.
nuts.
Well, yeah, grape nuts, but also just this bran cereal that was very much like just tree bark, shredded tree bark.
Oh, yeah.
That was just,
All bran.
and something
Yeah.
like that. But my mother
Well,
would use that same phrase,
yeah.
Andrea,
Eat your roughage.
that don't forget your roughage.
Roughage. Well, there was Fiber One that my father used to call Fiberoni. He's like, no, it's Italian.
So, Dr. Cooper, any last advice as we wrap things up?
No, but I just think that one thing that would be great, because I see a lot of patients who have GI distress a lot. And so they've eliminated a lot of these foods that we're saying are beneficial because they feel like they feel better when they don't eat them. So that's, I could understand doing that on a temporary basis, but I worry about people doing that over long periods of time, because then you're really depriving your gut of that, all the beneficial probiotic, prebiotic foods. And so I think it's important, if you're going to eliminate anything, to just do it short term and just try to start putting these things back in, and do it gradually, not all at once, so that you don't end up eliminating them again. So, but a little gas is okay. One of the things you were asking, Mark, before was like, is gassiness a good sign? But technically, it probably is a good sign that your flora is busy in there.
So they're eating and creating
Yeah,
gas as
right,
a byproduct,
exactly.
I guess, huh?
And so that's probably like, maybe you are on the right track with these like fermentable foods and things like that. But if you just go from sort of more, I guess what they say is the typical Western diet, although I don't see, my patients don't eat that way. Even, I mean, most people I know don't eat the typical Western diet. But if you did start out eating a diet that was very low in whole grains, beans, legumes, fruits, vegetables, plant proteins and stuff like that, and then you start changing your diet drastically, you will feel like it's a lot of work your gut's doing all of a sudden. So I think going in small steps is a smart idea, and just make gradual small step changes over time, and your gut will get used to it. It adapts, and we start to like induce new enzymes that help us break down foods if we're introducing our gut to new foods. It just takes a while.
Well, this has been super fun, learning about the interplay between bacteria and microbes and our health and our metabolism and our brains. So I guess it just really depends. It's just this beautiful symphony of things inside of us that lead to a balanced life and balanced health. So, well, this has been fun. Dr. Emily Cooper, Andrea Taylor, for another edition of Fat Science.
No diets, no agendas, just science that makes you feel better.
I'm Mark Wright. Thanks for listening to Fat Science with Dr. Emily Cooper, a Work P2P production. New episodes drop every Monday. If you've enjoyed the conversation, subscribe, rate, and review this podcast. This production is for informational purposes only and is not intended to replace professional medical advice. Join us next week for another episode dedicated to the science of why we get fat. No diets, no agendas, just science that makes you feel better.